Essentially, these are textures that can create bumpiness effects on object surfaces in rendering result. We can divide this type of texture into two categories: displacement and normal. Nowadays, the normal map usage is more common than the displacement. But let's discuss the displacement first, and then after that the normal map, as displacement is older and has fewer channels. Unlike the normal map that has RGB channels, the displacement texture is a single channel texture, meaning that it can be represented as a grayscale image. A long time ago, when computer graphics were quite young, we could only use this kind of texture to fake the shading. We can make 3D surfaces look bumpy at facing angles, but when we move the camera to a more perpendicular angle, we can start to see the surface is actually flat. That is why, back then, it was called a bump map, as it is only capable of generating fake bump effects on a model. Nowadays, we can use these textures to actually generate polygons that appear in rendering result. This process is what we call displacement. Since the technology exists, people have started naming these textures displacement or height map. Now, because 8-bit per channel images are limited to only 256 levels, a lot of people prefer to use high dynamic range images to store more height information in the texture. High dynamic range images are basically images that can store more than 8 bits per channel, such as HDR and EXR. Special variants of PNG and TIFF can also contain more than 8 bits per channel. So again, usually, bump texture has only the standard 8 bits per channel, while displacement and high texture usually has more than 8 bits per channel, and so commonly they are larger in file size. But there is nothing preventing people from naming 8-bit images as displacement or naming higher bit images as bump. Essentially, we handle these textures the same way inside Blender as they are all single channel images. For our practice, I have downloaded this free texture set from polyheaven.com called Large Square Pattern 01. I picked this one because it has both normal and displacement maps in one texture set. Let's assign this texture set to our plane object in Blender using the Node Wrangler add-on. First, let me just delete all of these nodes from the previous lesson. Then, while you have the principled node selected, press Shift-Ctrl-T to import the textures. Just select all of them, and then press this button to confirm the import. If we look at the result, we can see that the displacement texture is unique. Instead of being connected to the principled BSDF node, it connects to the main material output. Why is that? Well, this is because the displacement texture needs more access to alter the geometry and not just to control how the surface looks. Also notice that it uses non-color data for the color space, and it has to go through a special processing node called displacement. Inside this node, we can see a scale value that we can use to control the strength of the displacement effect. For now, let's unplug the normal map so we can just focus on previewing the displacement effect. Alright, the default scale value is 1. If we set this to 0, the bumpiness effect is completely gone. If we set this very high, like 10, the effect will look unrealistically strong. Let's just use 1 for now. This mid-level value controls the overall height level of the surface, but you can only see the effect in displacement mode, so let's leave it for now. Before we do anything, I think currently the lighting is distributed too evenly. To see the bump effect better, let's open the viewport rendering options and drag this down to around 0.2. Next, I know we haven't discussed lighting yet, but let's add a simple point light really quickly by pressing Shift-A, then type point, and then enter. Increase the power to about 1000 watt. And move this up a bit. Finally, I think we should hide the floor grid and also this axis. Okay. Now, if we move the point light around, you can see subtle shadows on the surface reacting to the light, mimicking the bumpiness of the original material in the real world. But if we rotate the view to see the surface from the side, we quickly realize that the surface is just a flat surface. Essentially, by default, Blender only performs the bump effect and does not use real geometry or so-called displacement. The reason for this is that displacement effects require more memory and processing power. They are only suitable for creating large noticeable objects such as terrain or very close-up objects. Again, this is why normal maps are more commonly used than the displacement maps. To activate the displacement effect, there are two things that you need to do. First, the model needs to have enough polygons to accommodate the effect. Second, you need to switch the bump mode to displacement mode manually in the material settings. Let's tackle these requirements one by one. First, we need to add faces to the plane object. For this, we can go to the solid view mode, then activate the edit mode. Select the face, right-click, and then choose subdivide. Let's make this all the way to 10. Let's divide again once by pressing Shift R to repeat the command. Okay. Let's go back to the rendering mode. The next requirement is the material settings. You can find this in the settings category. Remember, not the displacement, but the settings category. At least, it is how it is in Blender version 4.3. In the surface subcategory, you can find a displacement option. Notice that currently it is set to bump only. This is the reason why we only see bump effects on the surface. To activate displacement, you can either activate the displacement only mode, or better, use both displacement and bump for a more pronounced effect. In this condition, if we rotate the viewport around, we can see that this is not just a shading effect. Real geometry is being used here to define the bumpiness effect. Now we can try tweaking the mid-level value. As you can see, we can control the overall height of the surface using this value.